We are now moving into graphing quadratic equations or quadratic functions. So I'm going to just use this video here to run through some examples with you guys so that we don't spend so much time on Zoom, but here we are. Example 1, they want us to graph this guy. Y equals x squared plus 3. Then they want us to find the domain, find the range, and we can talk about this guy down here afterward, but let's go ahead and graph this. So right now we're going to start this out pretty simply by just creating an XY table. Later on we're going to do an extra step that helps us identify what values to start with for x. But for example 1, you can kind of just, for all of example 1 stuff, you can kind of just start artificially, at 0 and go kind of a couple to the left, couple to the right. So I always love to start these by seeing what happens at 0 because it's easy. If you plug a 0 in for x, notice that that's just 0 squared, which is 0, plus 3, which is 3. Okay, so at 0, we're at 3. All right, let's keep going. If we plug in a 1 squared plus 3 gives us 4, and negative 1 squared plus 3 also gives us 4. Okay, so at negative 1 we're at 4, at positive 1 we're at 4. Okay, then we're going to plug a 2 in. 2 squared is 4, plus 3 is 7. Negative 2 squared is 4, plus 3 is also 7. So at negative 2 we're at 7, and positive 2 are at 7. Okay, so notice here we have this graph that has symmetry through the origin. All right, so that means that the graph's going to show up the same on either side of that thing with a vertex here at 0, 3. They don't ask you about the vertex or anything like that for example 1. They just want you to get a picture going. Okay, so create your picture. Then they want the domain and the range. Okay, so remember the domain's possible x values. All right, you're choosing x values. You can plug in whatever you want for x. You can plug in 1,000,000 if you want, and it will be on the graph. It's just kind of ridiculous to get a picture of that, but it would be. So the domain here is that we can plug in anything we want, so all reals. The range, however, is the possible y values. Now notice, no matter what you plug into that equation, okay, even if you plug in like a negative 1,000 or something like that, if you plug in a negative 1,000 and you square it, you're going to get a ridiculous number plus 3, right? So it's going to keep going up, up, up. See if you can, don't waste too much time on it, but see if you can plug in something here that would allow this graph to go below this vertex, okay? Is there any points down in here? Hopefully you don't find any because there aren't any, but this thing will always start at the vertex. The vertex that we found in this case is 3. Okay, so the range will include 3 and then all y values above 3. So it's the y values where y is greater than or equal to 3. All right, that's your domain and range. Now, if you had y squared minus 1, just for fun here, notice what that would do if you plug a 0 in for this guy. You'd be at negative 1. Okay, if you plug a 1 in, you'd be at 0. Plug a 2 in, you'd be at 3, etc. So if you were to graph this, at 0 you're at negative 1. At 1, you're at 0. At 2, you're at 3. If you plug in a negative 1, you'd be at 0 as well, right? So we'd have this guy. And notice here that the vertex is at negative 1. So we'd have all reals for the domain, and the range would be y values where y is greater than or equal to negative 1. All right, so that's example 1. Example 2 says to find the vertex, the axis of symmetry, and the y-intercept. All right, so the vertex, you guys, is always either going to be, it's going to either be the highest point on the graph, which would be here in this case, or the lowest point on the graph, here in this case. Okay, so to identify that, it's just an xy coordinate. So this would be negative 1, 3. Right, so negative 1, 3 is our vertex. The axis of symmetry is just, if it's opening up and down, will always be an x value, and it's just the x value that we run through here. So it's x equals negative 1 is our axis. Okay, and the y-intercept is just the place where it crosses y. So in this case, the y-intercept we could just label it y-intercept is equal to 2. You could say 2 because it's the y-intercept. If you want the coordinate, it would always be 0, comma something. But this is fine if you label it y-intercept. We know that that is at 2. Let's go ahead and pause the video and see if you can do the second one here by yourself. And then start the video back up and see how you did. So for the second one here, the vertex is going to be at 1, 3. 1, 3. Okay, we have an axis that runs through that thing at x equals 1. We have a y-intercept that is at 0, 1, 2, 3. It looks like it's at 4, so we'll say 4. All right, so that's example 2, is just identifying some of those pieces. All right, then for example 3, 3a, it says find the vertex, the equation of axis of symmetry, and the y-intercept. So I'm going to review these things with you. So to find the vertex, you guys, the very first step that you want to do with this, well, the easiest thing to identify is the y-intercept. That's just, we know that a graph crosses the y whenever the x value equals 0, right? So if I plug a 0 in for this x here, this thing just goes to y equals -5. That's the y-intercept. Okay, so that's really easy. You can do that first off if you want. The axis of symmetry is the tricky part here. Okay, the equation for that is x is equal to -b/2a. So I have to identify here my a, b, c's. So if this is in standard form, right, if you've put it in standard form with the coefficients from highest to lowest, the a term will always be out front, the b term will always be the second, and the c term would be third. Okay, so we know that b in this case is 6, so we would plug it in. X equals -6 over 2 times a, which is 2 times -3. So that comes out to -6 over -6, or 1. Okay, so my equation for my axis of symmetry is x equals 1. Now to find the vertex, what I'm going to do is I'm going to take that thing, because look guys, the axis of symmetry, say we have a parabola that looks like this, the axis of symmetry will always run through the vertex at that x value. So I'm going to take this x value, I'm going to plug it back into the equation, okay, for x, to find out what the y value is right there. All right, so I'm going to plug it back in. Y is equal to -3 times 1 squared plus 6 times 1 minus 5. I just took that 1 and plugged it in for x. Okay, 1 squared is 1, 1 times -3 is -3, 6 times 1 is +6, minus 5. -3 plus 6 is 3, 3 minus 5 is -2. So I have a vertex. Notice here, you guys, that the axis will always be sharing the x value with the vertex on these. So the vertex will be 1, -2. Okay. And this, you know what, you guys, I kind of made a mistake here. I would, instead of saying y equals, I would say the y-intercept is equal to -5. Okay, so that's example 3a. Here's 3b, which I highly recommend you try on your own. But let's go ahead and do it. Pause the video, try it on your own, and then push play and see if you got it. So axis of symmetry, -b/2a. Okay, so this is always an x equals. So in this case, that would be -2/2 times 2, which is -2/4, which is -1/2. Okay, so your axis of symmetry is x equals -1/2. To find your vertex, we're going to plug that thing back in. So it'll be 2 times -1/2 squared plus 2 times -1/2 plus 2. Okay, so then when I do this out, -1/2 squared is 1/4, because -1 squared is 1, 2 squared is 4. So this is 2 times 1/4. Plus 2 times -1/2 would be -1. Plus 2. If you do this out, you get 2/4 plus, which is the same as 1/2. Instead of plus here, let's just say -1 plus 2. So 2/4 is 1/2, right? So 1/2 minus 1 gives us negative 1/2, plus 2 equals 1 and 1/2. Okay, so my vertex is at negative 1/2, 1 1/2. The y-intercept is nice and easy. You plug a 0 in, these go away, it's 2. Okay, and there's your 3 answers for example B, 3B. Next, let's cruise down to maximum and minimum values. So you guys, the vertex will always be the max or the min. If the leading coefficient thing in standard form, okay, if the A term is negative, that means this thing will always open down. If it's positive, it'll always open up. So notice, if A is negative, we will always be dealing with a max. So the max happens when A is negative. All right, so if it's opening up, that happens when A is positive. Okay, and notice that in this case, that vertex is a minimum. It's the lowest point on the graph. Here it was the highest, so we call it a max. Here it's the lowest, so we call it a min. All right, so then we go through a couple of examples there. Okay, so I'm not going to do those because I have some here that I'll do with you guys, and then I'll let you guys get on with it. So we have 2 more to go here. Example 4 says determine whether the function has a max or a min. Okay, well, since this is positive, we know it's going to open up, therefore it has a minimum. Okay, how do I find that minimum? I have to find the vertex. All right, so I'm going to do a negative b over 2a, which is negative. Now notice, oh, good thing when this came up. This is a negative, negative 4, right? Negative b is negative 4, right? Over 2 times 2. This gives us positive 4 over 4, which equals 1. Okay? Then I'm going to plug that back in for x in order to get my y value. All right, so 2 times 1 squared minus 4 times 1 minus 1. This gives me 2 minus 4 minus 1. 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3. So my vertex is 1, 3. Negative, sorry. So there's your vertex, and that is the minimum value. So then it says state the domain and range of the function. Okay, well, if that's my minimum value at 1, negative 3, this thing's going up, right? So my domain is going to be all reals. So I can plug in whatever value I want for x, this direction or this direction. But up and down direction, it starts here at negative 3. So it's the y values where y is greater than or equal to negative 3. Okay, so the graphing steps, pulling all these examples together. Here's what you do. You find the equation of the axis of symmetry. You find and plot the vertex after you plug the axis of symmetry value back in, okay? Figure out if it's a max or a min by looking at the a value, the first term, the first coefficient, I should say. Then number 3, find and plot the y-intercept, which means you're going to plug 0 in for x. Okay, then we're going to use symmetry to find the other points if necessary. Connect the points and form the curve, and we're done. So let's do all those steps in one of these, and then I'll be done here. Okay, so here we go. I guess I'll go in the same order here. So we'll find the axis of symmetry first. So 1, we'll find the axis of symmetry. Negative b over 2a equals x, right? So x is equal to, this is the x term of the vertex, by the way, which is the symmetry line. So negative b, it would be negative 2 over 2 times a, which is negative 2. Okay, got it from right there. This is negative 2 over negative 4, which is 1/2. Okay, so at 1/2, I have my symmetry line at x equals 1/2, which means my vertex is on that line someplace. To find out where it is, I'm going to plug in 1/2 for x. So negative 2 times 1/2 squared plus 2 times 1/2. Notice how I use parentheses when I plug those things in. 1/2 squared is 1/4, so this is negative 2 times 1/4. Okay, don't say negative 2 1/4. That's not what it's saying. It's negative 2 times 1/4 plus 2 times 1/2, which is 1 minus 1. 1 minus 1 is just 0, so it's just going to be negative 2 times 1 over 4, which is negative 2 over 4, or negative 1/2. Okay, so at 1/2, negative 1/2, we have our vertex. Okay, so now we've done that, number 2, and it says to determine if it's a max or a min. Well, in this case, since this is a negative, this is our maximum point, so we're going to be going down here. Okay, I know I'm going to be going down. All right, so then it says find and plot the y-intercept. Well, if you plug a 0 in here, that's at negative 1. Okay, so at negative 1 we have something, and then here on the opposite side we have 1. Cool. Then once we've done that, after the y-intercept, it says to use symmetry to find the other points if necessary. So I could just choose something random. I can just, like on an XY table, I can choose something to the right or something to the left. Let's choose 2 just to see what happens. So if I do 2, if I plug a 2 in, I'd have negative 2 times 2 squared plus 2 times 2 minus 1. This is negative 8 plus 4 minus 1. Negative 8 plus 4 is negative 4 minus 1, which equals negative 5. So at 2, I'm at negative 5. And notice, since this is symmetrical across this point, this dotted line here, I can also, without doing any math, create a point over here that's the same distance away from that symmetry line. Okay, so once I have a couple of those, I'm good to go, and we're done. Okay, so don't pay attention to this homework necessarily, just do the homework sheet that I have on Classroom. All right, guys, that's it.